All right, so today we're going to be talking specifically about the law of sines. So, if you are watching this video, what I would do is I would totally pause it right here and write things down. But right now, I'm not going to make my class do this because they'll be in class. And basically, this is the law of sines, and I want you to put this in your journal. You don't have to put this area formula right here. You don't necessarily need it for today, but these are the area formulas if you wanted to use the law of sines to find the area of any triangles. Those are the area formulas. And this deals with what's called the ambiguous case, which we're not going to go over today. But right now, today, all you got to do, today, class, put that baby right there in your journal. I'm going to pause because I'm making sure my class gets this in their journal right now. Now, something you guys need to be aware of, all right? A, B, and C. If it's lowercase, it's referring to the length of a side. So these are all lengths of individual sides, okay? But if you see a capital letter, a capital letter, a capital letter, in fact, how about this? I'll just kind of put a little arrow going to all of them, okay? That represents the measure of an angle. All right, so capital letters represent measures of angles, lowercase letters represent measures of sides. That will always be the case. So if we go over here to our particular problem, all right, we're going to solve this using the law of sines. What I'd like you to do, when you draw this picture, you'll notice it has A, B, and C, all capital letters. But what I want you guys to do is I'd like you, across from capital A, put a little lowercase a. And across from capital C, put a lowercase c. And across from capital B, put a lowercase b. All right, the sides are always opposite whatever the angle is. So if you have a capital A, that opens up to lowercase a. If you have a capital C, that opens up to lowercase c. Now, from your previous picture that I had, it's A over sine of capital A equals B over sine of capital B equals C over sine of capital C. We're not going to use all three. All we got to use is 2 out of the 3. So which ones do you think we're going to be utilizing? I'm not going to give you guys any hints whatsoever. What do you think? Oh, we are searching. Hold on. BC, which is, there we go. So here, you see right here, we got to find what? The distance from what? B to C, which means we got to find this sucker right there. So what we're going to do is we're going to use this one. Sound effects are free. And we're going to use this. So what am I going to set up? A over sine of A equals C over sine of C. So if you would please, just do this with me. What is lowercase a? I don't know. So I'm going to put lowercase a times the sine of, what's angle A? 84, so I put 84. Equals C, what's lowercase c? 16 over the sine of capital C, which is 51, so I put 51. There we go. So right now, nice and neat. Could you please write that down in your journal? Because over here on the blackboard, I'm going to solve it for us. After you write it down, what I'd like you to do is I would like you to take the cross products, please. Take the cross products. Now the cross products are A times the sine of 51 degrees equals 16 times the sine of 84 degrees. So these are the cross products. A times this, 16 times this. So literally, after we have it set up, we got one step and only one step only. What are we going to divide both sides by? The sine of 51 degrees. These will cancel out. A is going to be an approximate value, and this is where please make sure your calculator is in degree mode. I implore you. If you don't know what implore means, it's like I beg you, like I'm really stressing, put degree mode, okay? All right, so here we go. Turning on my old graphing calculator. Making sure if you ever do second plus 712, that changes you to degree mode. So make sure your mode's in, sorry, it changes you to radian mode. Make sure you're in degree mode, okay? And then hit alpha y equals enter. And in the numerator, we're going to type in 16 sine 84. So I'm just going to type in 16 sine 84. In the denominator, I'm going to type in sine of 51. Like that. And press enter. I'm going to get 20.475. 20.475. 20.475. Let's see what it asks for. Oh, round it to the nearest tenth. Yay, that's easy. What are we going to round this sucker to the nearest tenth? 20.5. And I am done. Now let's say you don't have a graphing calculator at home, but you do have this thing called Desmos. Check this out. So let's go to, some people don't have graphing calculators, and that's okay. I'm just going to go to Desmos real quick. Even if I did test mode, it'll still work. The only thing is you got to make sure you're in degree mode. So I could make a little fraction bar right here. And it was 16, was it sine 84? And then this was divided by the sine of 51. So even if you don't have a graphing calculator at home, you could still do this on your phone and type it in. Okay, so I just want to make sure you know you have access to both. But make sure you hit the little wrench here and make sure it's in not radians. That would be bad. See, look at radians. Bad. Degrees, good. Radians, bad. Degrees, good. Okay. 20.5. All right, very good, very good. Let's do one more, okay? And then I'll let you guys get this one done. Then we'll talk about the law of cosines. All right. All right, so right now I'm going to draw this picture. I'm done. All right, so I'll give you guys a chance to draw your picture. I'm going to put a little arc here. Put a little arrow going across. Make sure I label that lowercase c. All right. And then, ooh, it says find the measure of angle B. So I'm gonna put another arrow going across. That is lowercase b. So the first one we did was finding a side. This is the next one we're going to do. It's called finding an angle. So I just wanted to make sure you guys know what we're doing here. So right now, since we're using C and B, I'm going to write lowercase b over the sine of b equals lowercase c over the sine of c. So I'm going to give my students a chance to draw this in their journal because I got to give them a chance to draw it because, yeah. All right, so guys, what am I going to put for lowercase b? What length is lowercase b? And all the kids who aren't paying attention say 11. Good job. All right. And I'm going to put the sine of capital B equals lowercase c, which is 12, over the sine of 73 degrees. Now, guys, I just want you guys to understand, when you're doing this, you guys see how close the lengths of the sides are? If the lengths of the sides are close to each other, guess what about the measures of the angles? They'll probably be pretty close to each other as well. Okay? So if you get an answer that's close to 73 but a little bit less than it, then that's a good idea that you probably got the right answer. So let's go ahead. That's just kind of a way of checking yourself. If you guys do something and all of a sudden you get like 40-something degrees, you did something wrong, is what I'm telling you. These angles will be pretty close to each other. So let's go and do a little cross multiplication. Won't take long. All right, so what's one of my cross products? What do you guys say? 12 times the what? Sine of b. So I'm going to write 12 times the sine of b equals 11 times the sine of 73. 11 times the sine of 73 degrees. Now, ultimately, I'm trying to find what the heck the measure of this angle is. But before I do that, I got to divide both sides by this 12. So these 12s will cancel out, and I'm left with the sine of capital B equals 11 sine times 73 degrees over 12. Now, do you guys remember from the last section when you're dealing with right triangles, if you're trying to find the measure of the angle, what's the last thing that you have to do? Find the what? The inverse. So what I'm going to apply the inverse on this side and apply the inverse on this side. The signs cancel out, so B will equal what's called the inverse of sine. And what you got to do is you got to stick this whole thing right here. Whatever you get right here, you got to stick inside of that parentheses, and then it will give you the approximate value of the angle. So I'm going to go ahead and type this in nice and neat. So I'll go to my calculator. I will hit second sine. Then I will hit alpha y equals enter. I'll go back and look at my 11 sine 73 over 12. So I type in 11 sine 73, and I put it over 12, and I close the parentheses, and that gives me 61.2 degrees. All right, 61.2. Well, you know what? That's not super far away from 73. So I'm going to put 61.2. My apologies. Dude, come on, man. All right, 61.2 degrees. And it says rounded to the nearest, rounded to the nearest degree. So I'm just going to put 61. Nearest degree, 61. Okay. Let's see here, AC. Okay, so this is another one, finding the measure of the side. So right now, understand, you're either finding one of two things, right? You're trying to find the what? The measure of an angle, or you're trying to find the measure of a side using the law of sines. So you guys go ahead and work on that. I will help you here in class. Everybody else, you have to wait. We're going to be doing the law of cosines here in a second. All right, here's a quick little preview of what we're going to be doing next. Oh, not that. Right here. This is called the law of cosines. All right, so I'll give you a chance for those of you who are wanting to write that down in their journal. There's the law of cosines. But I'm going to pause the video because I still have people working on the law of sines. All right, so in the law of cosines, you guys need to know the difference. Like, when do we use the law of sines and when do we use the law of cosines? So I'm going to scroll over here real quick, take a picture of the law of sines. We're going to compare when do we use this, all right, and when do we use this. Here's what I want you guys to understand. You've probably heard of those triangle proofs in geometry where you had side, side, side. If you have a triangle where all they give you is all three sides, you're going to use the law of cosines. If you have a side, angle, side triangle, you're going to use the law of cosines. You use the law of sines when you have an angle, and a side, or an angle, side, angle. If they only give you one side, everybody, if they only give you one side, you're going to have to use the law of sines. But if they only give you one angle and two sides, then you're going to use what's called the law of cosines. All right? Now, sometimes you can use the law of sines for side, side, angle, but you got to be careful because there's called an ambiguous case, which we're not going to run into today, but there might be an ambiguous case where it doesn't work, and that just makes the opposite of this of you and me. Okay, so we got to be careful of that. All right, so here we go. Law of cosines. Ready? We're going to be doing the law of cosines, and we'll make sure you guys know how to utilize it. So right now, I'm going to go over here. It says solve a triangle using the law of cosines. Does everybody see right here in this triangle that we have a side, an angle, and a side. So we have a side, angle, side. So we're going to use the law of cosine. So here's how it works. Here's capital C. So what is this side? Lowercase c. This is capital A, so this is lowercase a. This is capital B, so this is lowercase b. Now, it's important that you know which formula that you need to be using. I'm only highlighting the most important part. So I'm going to go back real quick. We're going to take a look. Do you guys see where it has A, B, and C? So listen. Do you see how we're looking for side C? So this is what we start with. So start with C squared equals A squared plus B squared minus 2AB times the cosine of capital C. I'm not expecting you to memorize this. I'm expecting you to have it in your journal and you use the correct one. So that's what we start with. We start with this guy right here. Now this one's going to be super easy, all right? You literally, all you got to do is literally plug in the numbers and press enter. So what is my length of A? 6. What's my length of B? 7. My length of A? 6. My length of B? 7. Cosine? 59. Now, here's the only thing you got to remember to do. This is what students will forget. They will forget that this is c squared, so technically I need to take what's called the square root. So I usually do that at the end. Okay? So if you would, please go to your calculators. It's super easy. Just go up here. I open up parentheses. I put 6 squared plus, what was the other side, 7? Squared minus 2 times 6 times 7. And then type in the cosine of, what was our degree? 59. Type in 59. And I press enter. But what do I have to do the last step? Take the square root of that guy. Voila. 6.46, so 6.5. So that's approximately equal to 6.5. So when you have a side angle side, and all you got to do is find this missing one, it's super easy. You just plug it in and take the square root, and you are finished. All right, so let's type it in. So you guys know that I'm telling you the truth and I'm not lying. All right. All right. Now, this one right here is a little bit different. So this one you'll notice we have side, side, side. So this is the last one we're going to do today. So if you guys could draw this out, that would be fantastic. All right, so on this one, guys, it's important to know which angle you're looking for. This is angle A right here. That's what we're looking for. So this right here, guys, this is lowercase a. This is capital B, so this is lowercase b. This is capital C, which means this is lowercase c. Now, if we're trying to find the measure of angle A, then you need to please start out with A squared. So put A squared equals B squared plus C squared minus 2BC times the cosine of capital A. It's super important that if you're trying to find the measure of angle A, that you lead with the lowercase a. So right now, I'm going to plug our numbers in. We have 6 squared equals 12 squared plus 14 squared minus 2 times B times C times the cosine of A. Now this is where students will mess up. And I want to make sure you guys do things. So could you please put a box around the 6 squared, put a box around this, and put a box around this. Like, you guys need to do these 3 things separately. Do 6 squared by itself and put 36. Then do 12 squared plus 14 squared. Which is 340. So put equals 340. And then do negative 2 times 12 times 14. So negative 2 times 12 times 14, negative 336 minus 336 times the cosine of A. You have to do this separate from this, which is separate from this. That's what makes this one. That's what makes this one harder. Do not subtract these. You cannot do 340 minus 336 because this is technically being multiplied by the cosine of A. So the next step, you better take away 340 from this side, and you better take away 340 from this side. These will zero out. When you do 36 minus 340, you get negative 304. That's super important. So we have negative 304 equals a negative 336 times the cosine of A. These negatives on either side will eventually cancel each other out. So when I divide both sides by negative 336, these guys cancel out. These become a positive. So you have the cosine of A equals this fraction, which is 304 over 336. All I want you to know is you don't have to simplify it. All you have to do is do the inverse of it, and you're done. So capital A is equal to the inverse of cosine of 304 over 336. So I got to type this in, and that will give me my approximate value. Now, yes, I will do more of this tomorrow because I realize seeing it one time isn't going to make a lot of sense for some of you, but I will put this on a video. I'm putting this on video so you guys can watch the steps. The steps stay the same. So I do the inverse of cosine. I type in 304 divided by 336. I trust in the process. It gives me 25.2, so I know my degree is 25.2 degrees, but I think it asks me for the nearest degree, so I'm just going to put 25 degrees and not the 25.2. All right, so nearest degree is 25. Okay, so I do plan on doing more of those tomorrow, but that's your first example.